In this video, we'll be talking about solving a quadratic inequality that's already written in factored form. Okay, so recall that the graph of a quadratic is a parabola. Okay, so what we're going to do on this is we're going to put the x-intercepts on the number line, which is we're going to set those equal to 0, each factor equal to 0 and solve. And if you have a strictly less than or greater than sign, like this one right here, then you'll use the open dot. So like this and like this. And if you have the less than or equal to sign like this one, then you'll use the closed dot. Okay. So we will ask is it facing up or down, and then we'll kind of sketch the graph in relationship to 0. Okay, so we look at this first one. It's x times x minus 6 is less than or equal to 0. And we could, just so we can understand what this graph looks like, we can distribute that, and it would be x squared minus 6x. Okay, so this is the function we're looking at, and we know that that's a parabola, and we know that it's going to look like this. It's opening upward because the number in front of the x squared is positive. So we know kind of the shape of the graph. Now we're going to see where it crosses the x-axis here. And in order to do that, we set each individual factor equal to 0. So the first factor we have is just this x right here. So if you set that equal to 0, well, it's already solved for you. It's x equals 0. And the other factor, x minus 6, is equal to 0. If we add 6 to both sides, this becomes x equals 6. So we know we've got two places on the number line, one right here at 0 and one right here at 6. Okay, and since the inequality sign has a less than or equal to, we're going to put solid dots there. Okay, so we know that it's either going to be, it's part of this region has to be filled up, and we know that the parabola is going to look like this. Okay, so if it's asking us where we're less than 0, that's going to be where we're under the x-axis there. Okay, so it looks like it's going to be this part down here, or this part here, that is going to be shaded. Okay, but to test that, you can test out some numbers. So we will test out this region here first. We need to choose a number that's less than 0. It doesn't matter what it is. Let's just choose the easiest one that's less than 0. That would be -1. Okay, so if we plugged in a -1 into this right here, so we test x equals -1, we'd get -1 times -1 minus 6. Okay, that is going to be a negative times a negative, which is a positive. It would end up being +7. So the problem is asking us where it's less than or equal to 0. So we tried this region over here, and we got an answer that was bigger than 0. So this will not be part of the solution here. So I'll just put an X on that part right there. Okay, and let's try a number here in the middle between 0 and 6. Doesn't matter what it is. Let's just say 1. Okay, so we'll try 1 because it would be right here in this region. So we'll test x equals 1. So that would give you 1 when you plug it in there, and then 1 minus 6. Okay, so that's going to be 1 times -5, which is -5, and that is less than or equal to 0. So this is a check mark. That region in the middle is good. Okay, and then we try the third region, which is over here, bigger than the 6. And we should already know by now, because we know it's a parabola, we know that, okay, the middle part's less than 0 and the outer parts aren't. But let's try one more. So we test, let's test something over here like x equals 7. It could be 7, 8, 9, 10, whatever you want to test, but I'm just picking x equals 7. So I'll plug in that 7, and I get, let's see, 7 minus 6. So that would be 7 times 1, which is 7. So that's bigger than 0. So this area is not good. So my shaded region that I'm going to have is going to be this one right here, just like I knew it would because it's a parabola facing upward. Okay, so that's the region between 0 and 6, and it includes 0 and 6. Okay. All right, looking at this one, if I do it looking at the parabola, if I multiply this out, let's see, I'll get x squared. Let's see, I'd get a -5x and a 4x, so that's -x, and then minus 20. Okay, so that's another parabola facing upward. Okay, so it's going to look like this. We know that already. And it's asking us where we're greater than 0. Okay, so we're going to be looking at the edges, right? We set each one of these factors equal to 0 and solve. Plus 4 equals 0. Let's see, that gives you x equals 5. And this gives you x equals -4. Okay, so we've got -4 here, and we've got +5 here. Okay, so I'm not going to do the test region this time because I know this is a parabola and I know it faces upward because it's positive in front of the x squared. So I know the graph would look like this. Okay, so I know that on a number line, I'm going to be, if I want it to be bigger than 0, it'd be this part. Parabola is going up here, and it would be this part. Okay, and as far as the points themselves, it says strictly greater than 0, not greater than or equal to. So I'm going to put a open dot and an open dot. Now, if I was to draw the parabola, just to help understand what we're doing here, if I was to draw a parabola on that, it would look like this, and it would look like this. Okay, so that's the graph of this right here. And if you're asked, when is it greater than 0? Well, when is it above this axis? Well, it's above it over here, and it's above it over here. Okay, let's look at that third one there. We've got x minus 1 times x plus 5 is less than or equal to 0. So if we distribute that, that'd be x squared plus 4x minus 5. So again, it's a parabola facing upward. Okay, so we set each one of these individual terms equal to 0. And that would give you x equals 1. And that gives you x equals negative 5. So we've got one here at negative 5. And we've got here one here at 1. And we know the parabola is going to look like this. It's opening upward. It's hitting these two spots. And it's asking us where is it less than or equal to. So if you think about the parabola, it's going to be below the line in between them. It's going to be above the line on these outside parts. So we know that it's less than or equal to 0 in between those two. And since it says less than or equal, we put a solid dot on each one of those. Okay.